Hi, I want to build a Arduino car that can draw. So the idea is that there will be two wheels controlled by stepper motors like these. I bought these a while ago for another project, but I still have them laying around. And so, yeah, what I want to do is, this is a laminated copper plate for making a PCB. I want the car to drive around, and there will be a pen in the middle. So as it drives around, it will paint or draw the circuit diagram on the PCB, and then I can etch it and finish my PCB. I really don't like the toner transfer method, so I want to build a small robot for that, and of course it's a fun project, so why not? So these are really cheap stepper motors, and with an accompanying driver. You can buy two of these, so two motors and two drivers, on eBay for something like $5, of course free shipment. This is an ULN2003 driver, and this what's particular about this stepper motor, apart from the fact that it's very cheap, is that it has an internal gearbox, which is really something you don't normally find in stepper motors. And of course what gives it away is that the axle isn't in the middle like with a normal stepper motor, but it's to the side because there are gears here. Now, of course, a downside of such a configuration is that you lose the turning speed of the internal electric motor, because it's a step down ratio, of course. So this doesn't turn very fast. The advantage is that for such a cheap, tiny engine, you really get a lot of a higher resolution per step, because the electric motor has something like a 5-degree per step resolution, which is really very, very high. But this, because of the step down gear ratio, this makes 4096 steps per rotation. So if you attach a wheel to this, say a 6.5 centimeter diameter, which is a typical diameter for the wheels on remote controlled cars. If you attach that wheel, and so you take the circumference of the wheel and you divide that by 4096, you get something like 0.05 millimeter per step, which is of course an incredibly small resolution, which is good for my purposes, because I want this car really to be very precise. And the advantage of a stepper motor is that you know where the motor is, you know how many steps it has done, so you can exactly know what its position is on its plane, where it's driving. So you can, with this board, you can hook it up to an Arduino without any additional components. You don't need capacitors or resistors or whatever. And I have an Arduino Nano here on its expansion board. This is really a nice little expansion board made for the Nano. So it basically expands all the pins and so for each digital pin you get 3 headers, which is of course very practical. By the way, the form factor of this board is that of the regular Arduino Uno. So if you would put male headers here, you could plug this into a Arduino Uno. Of course you would have to remove the nano, but yeah, so you can also use it for that. So I have a small power supply here, which is also something I can recommend. I think it's $1.30 on eBay, and it has you can select between 5 volts and 3.3 volts on each rail. So I have it in the 5 volt configuration. So I put a stepper sketch on the Arduino because one downside of this this driver is that you have to, so you have 4 pins, and each pin, if you put a combination of these 4 pins high, you're on a different coil of the stepper motor. So what it means is that you have to cycle through the pins of the driver board to make the engine turn, the motor turn. So let's do a quick demo. Okay, yellow is ground, so I'm gonna hook up the Arduino to the power supply, and then I need my cables. So let's see, pin 0 goes to pin 10, pin 1 goes to pin 11, pin 2 goes to pin 12, and pin 3 goes to pin 13. Now I need to power the driver. You really have to be careful with this board because, for example, the Arduino has clearly indicated which pin is ground and which pin is plus 5 volts. But this board doesn't have any indication. I actually managed to put the power the wrong way around, so I put 5 volt to ground and 5 volt put to ground. That's of course the bad part, and I powered it on and this chip got very hot, so I was afraid I damaged my board, but amazingly it survived. It still works perfectly. So let's see, blue is 5 volts. No, blue is ground, of course, and so now I already know by heart that the inside pin is 5, the outside pin is ground. Okay, so if I power on, let's double check, yeah? Let's double check. Green is ground, okay, blue is ground. If I power on the Arduino, the engine will turn, and I will hold it like this, so you can see the movement of the engine. Yeah, you can see it turning. So this is really the right kind of engine for me, I think. First of all, it's very cheap. I already have them, by the way, so that's another good reason to use them. They are slow, but I don't need speed. I need precision over speed. They're very slow, actually. So if you again, look how long it takes for one rotation. I mean, if you imagine powering a car with this engine, it's gonna be very slow, but yeah. By the way, I can actually hook up the second engine if I want to. Let's take 4 cables. Okay. So if I plug them onto the same pins, oh, I took 5. Oh well, I took 5 and I got the order wrong. I took 5 instead of 4. And green, and so yellow is not connected. So pin 1 is gray. Yep. Oh, pin 0 rather is gray. Pin 1 is purple, and then blue and green. Blue and green. And then I need to power the second driver. Let's make sure I take 2. Okay. Okay, let's take black for ground. Black, ground, white, 5 volts. Okay. Let's take both engines. Let's power it on. Oops, this is becoming very hot. So that's interesting. So both engines are drawing too much power. The voltage regulator got so hot I couldn't hold my finger on it. So let's fuck. You see, I did it again. I again hooked them on in the wrong position. So it now I've done that with both boards. Great. Oh my. You've probably seen that what I was doing and yelling at me for the second one isn't turning. Probably because I fried it, huh? Oh man, that's so stupid. I fried my board. Let's disconnect this one. Yeah. Well, you saw it first. I did the same thing to the other board and it survived. But this one didn't. Luckily they're cheap, but still. Let that be a lesson for you boys and girls. Really be careful with these boards because I'm definitely gonna order 2 more for in case I make the same mistake again. Oh man. Oh well. That's electronics for you. Blow my board. Yeah, that's the only possible explanation. Because otherwise everything is correctly wired. I mean, even if it wasn't correctly wired, I should get at least some kind of movement from this engine. But I mean, the wiring is correct. It's green, purple, blue, and green. Oh, gray, purple, blue, and green. Gray, purple, blue, and green. Yeah. Nope. No movement at all. I mean, the LED also doesn't flash, because with the other board, now let's be very careful. Ground is outside. So blue is ground, ground is outside, 5 volts is inside. With the other board, you'll be able to see, let me hold it like this. So you will see that as it powers on, this LED flashes, and then the engine starts starting. And with the other board that doesn't happen anymore, so I definitely blew that. Oh well. Great start for my Arduino car project. Well, let's not be too pessimistic, but let it be a lesson. Okay, so let's put this things aside. Back to the copper plate. What I didn't notice before is that these plates aren't flat. When I put them down, you can see that the outer sections are touching but the inside is not. I can push it down, and it's gonna really be a problem for my little car, because it really needs a flat surface. Another problem, by the way, that I somehow have to resolve is that even if it's flat, there is this edge, and I haven't measured it, but I would estimate that it's at least, yeah, something like 1 millimeter thick. But as my car drives over it, it's gonna disturb its position. I mean, the wheel is gonna drive over it, but I'm afraid it's gonna, you know, skip a step or something, or slip, and each step that doesn't result in movement is gonna affect the accuracy. And if it keeps driving on and off the board, it's really not good. And another problem is that if one wheel is on the board and the other one is off the board, then the pen, I don't have a pen here, let's say that this is my pen. If this is the straight position of the pen, I'm gonna exaggerate of course, but then the pen is gonna be something like this, because the base of the car isn't even. When one wheel is here and one wheel is here, it's gonna be off by a very small angle, but enough for the pen to be positioned like this. Now, in itself, that's not a problem, because I'm gonna have to provide some kind of frame for the car, you know, 2 vertical sides where the motors will be attached, and on the other side the wheel, and then yes, place to mount the Arduino and so on. So I'm gonna have to provide that, but I'm also gonna make sure that the pen is in the middle of the car, so even if the pen is like this, it's not gonna be in the middle, is it? Let's think about this. Yeah, I guess it's gonna be in the middle, because, yeah, I'm not sure actually, because the wheels are the base of the car, so if the wheels are even, yeah, I don't know. Anyway, so I have to find a solution for dealing with this edge. And what I was thinking about is that I put, for example, a number of PCBs side by side. Of course, they're not flat, so that's a problem, but I mean, you can still feel this edge here if I put them side by side, but it's really very, very small. So I don't think it will be a problem for the car anymore. Does that also mean that the thickness of these boards isn't even? Here the edge is less, and here the edge, it's also less. Oh, I don't know what happened there. But anyway, so if this is the work piece, then if I put, you know, these other boards side by side or something like this, and then another one and so on, that provides an even plane for the car to drive around. Now that's going to solve the problem of the edge, but it's going to introduce new problems, or at least limitations. So one of the limitations is, say that I make a diagram for a small PCB. So let's say this big. So of course I'm gonna cut out this part, and I'm gonna be left with this plate except for the top right corner. Now if I then want to use that PCB again, or this plate again, for another PCB, for example on the left hand side, how is that gonna work out? Because now you have this hole where maybe the wheel can get into as well. So one thing I was thinking about is to in the software or in the configuration of the car indicate that this area is off limits for the wheel. So then the car would have to find, so for example if it would have to draw here or something, it shouldn't drive like this, because if it drives like this, its wheel is going to end up in the area that's off limits. So it's probably going to have to drive like this, and if the rail goes in this direction, then it will have to work like a printer, you know. It's gonna have to make two dots and then turn, go back and a little bit further, another few dots, and so on. So that's another, I mean, I say dots, but of course the car can draw a line too, but that's something else to consider, and certainly a limitation of this method. By the way, if you look on YouTube, for example, and you search for drawing robot, you will find all kinds of designs, including cars, but the cars that I saw on YouTube weren't really precise. So there was one car that drew a rectangle, and then again and again, and each consecutive rectangle was off from the first one, although it was supposed to be the same coordinates. So that's something else. I mean, that car didn't have encoders on its engine, and of course a stepper motor. Let's connect these ones. This is my this is my board driver, by the way. These steppers don't have encoders, but yeah, they work in steps. So if the Arduino sends one step, it knows what has happened. I mean, apart from if you don't consider slippage of the wheels and so on, spinning of the wheels, then one step will move that wheel ahead a certain amount. And so but the car on YouTube doesn't have that encoding. It doesn't have an encoder, or it also doesn't use a stepper motor. So of course it's going to be off, because you rely on the fact that both engines work synchronously, but of course that's never going to happen. There's also always going to be friction and play and error margins and whatever that makes so that even after drawing one rectangle, you already are off. So by using stepper motors, I hope I can avoid that. So I think that's been already enough for this video. Yeah, I'm gonna make another video. I'm not really sure what I mean, I have so much to talk about. Yeah, I'll probably make a video on the design of the frame for the car, because I'm gonna have it laser cut and so I'll probably do a video on that. But yeah, that's it for now. Bye bye.